Hello students, this is Dr. Dias and I'm here to talk a little bit about regioselective and stereoselective. This is the second time I'm trying to record this video because YouTuber doesn't allow me a long video, so I will try to be shorter. So this is why I wrote down everything before we start talking. So regioselective is the formation of one constitutional isomer over another. For example, when we have the major as side self, that we can have an E1 that we always have. The priority is for, like, the major products will be side self because it's more stable, so look for stability. And the stereoselective, think about E and Z. Okay, so stereoselective is when you have so we're gonna have E and Z, or we're gonna have which one is the major. So this is stereoselective. So stereospecific, we can remember the SN2 reactions. So since we have a concerted reaction, I mean everything happened in one single step, so breaking the old bond with the halogen and forming a new bond. This is concerted, so everything happened at one time. So this is stereospecific because the stereochemistry of our initial compound over here will determine that we'll call here initial compound will determine the my final product over here. So if I have R over here, I'm gonna have S at the end, okay? So that is stereospecific because that is not other way, because you know the SN2, the nucleophile will attack here in the back exactly 180 degrees. So the nucleophile will attack over here. The lowest unoccupied molecular orbital, so which is exactly 180 degrees from the leaving group. So this is why it's a regiospecific, stereospecific. Sorry. And then we have stereoselective. A good example would be E1. So this is not stereospecific. So in this, we're gonna have the major product will be E. So we have, and we have like in between both over here, we have 1, 2, 3, 4, right? So I have here, well, not this. I have 1, 2, 3 substituents, and here 1, 2, 3 substituents. So both are tri-substituted. But what changed here is the position of our Buckus group. So always think about to check this. You can tell me, oh, you have a 2 methyl group. How do you know? So you need to look in each carbon here who is the priority. So on this side, I know this is my priority, and in this side, I know this is my priority. Over this, I feel this group here will be priority because we have more different things over here so happening, right? Carbon, carbon, and carbon. And here I only have carbon attached to hydrogens over here, so this is the priority, and they are in trans position over here that we call E and or Z. When they have C's, they are in the same side here, so my priority is over here. So this is stereoselective because we can have both happening over here. We can have a hydride shift and a high shift. So we're going to have 2 products, but the major will be here, the E. And also another example would be the elimination 2, which is there is a requirement of anti-arrangement between carbon and hydrogen and carbon a leaving group, remember that I said? So they need to be an anti-position. So I have my hydrogen here and I have my leaving group over here. So when we have our final product, I know the stereochemistry of the initial, my initial molecule over here will determine the final over here. So, and also here I have a E, so because they are in transposition, but this is the only isomer that I can produce. So in this case, I have a stereochemistry because the first the initial the stereochemistry of the molecule, my initial molecule, will determine the stereochemistry of my final molecule. Okay, so that's it. That's all. I hope you understand a little bit more about selectivity. And if you have more questions, please send me email. This was a question from a student that sent by email. So I'm answer his question through this small video, short video. So I hope that helps. And if someone else has the same question, here is the answer. So have a great weekend. That's it. That's all.